So now we're going to talk about some advanced data types beyond just string equals spam. We'll be talking about really 4 built-in types. Can everyone hear me okay? Try to get a mic. We'll be talking about 4 built-in types. And we'll just go in order: list, tuple or tuple, sets, and dictionaries. And the way to think about all of these is that they're essentially sequences of objects. Some of them are changeable, some of them are not changeable or immutable, and they all have different properties, and you're going to wind up using them, not necessarily all of them in every code, but many times you'll wind up using different types to sort of satisfy different needs within your code. So I'm going to start off with tuples, and what I'm going to do is present this to you through the notebook. I think I can just get rid of that. So this is the IPython notebook, and you see I've basically kind of laid out where we're going to go with all of this, and I haven't told you the results of any of it yet. So this is sort of a nice thing, I think, hopefully for teaching purposes, that you can have this notebook saved. In fact, we have the PDF of this notebook, a raw version of the notebook, and also a markup version of this notebook, also linked from the website. Okay, so tuples. Those are denoted with parentheses. So if I go to this first cell right here, I say t equals 12 minus 1, and I can print the type of that. Hopefully. It's not working. I have to dump out things. Run selected. Yeah, it should just work though when I'm typing. Oh, I'll just do this one. Okay, so there's our answer for our first one. So I just created some object called a tuple. And if I want to now ask is t of type tuple, and ask for the length of that, I get true, and length is 2. So now we think of what the tuple contains as basically a bunch of different elements. So now I'm up here in 3. T equals 12, Monty, true, minus 1.23 exponent 6. You notice right away that if this doesn't give me an error message, then it means that tuples can contain a mixed different type of variables. So here's an int, here's a string, here's a boolean, here's a float. And if I print the first element of that tuple, not 0, there's the first one. I get back Monty. Okay, that's really nice. All of these things that we'll be talking about essentially can contain a heterogeneous set of objects or variables inside of them. So you could have dictionaries and tuples all sort of interleaved with, inside of each other. Okay, t minus 1. What's that going to print for me? What's the minus 1th element of the tuple? Minus 1.23, yes, exactly. And notice it didn't print out this, it printed out the string representation of that. Okay? Minus 2 to the end. So I'll get the last 2 elements, and I'm going to return that as a tuple. So we're basically using the same sort of notation that we had when we were slicing and dicing up the strings. True and minus whatever. Okay, now this is an important thing in constructing tuples. X is equal to, just like I said, parentheses, true. And I'll ask for the type of X. Then I'll say X is equal to true, comma. If you put parentheses around something, what Python natively wants to do is just evaluate it. So Python just put parentheses around it. It's as if I said X times 5 equals, or plus 4, right? And it would just evaluate that. That's what these parentheses mean to the Python interpreter. So to say, no, I really just wanted a 1-element tuple, you actually have to add a comma afterwards. This is a little bit of a quirk, but hopefully it should make sense. So if I ask for the type of this empty thing here, I'm going to wind up getting a tuple without the comma. If you try to create a tuple with a comma and nothing else, it will complain at you and say, I don't know what you're talking about here. So if you want one element, you need to do that element and a comma. If you want a no element tuple, because that's how you roll, you just want to do it with open and close parentheses. The length of open and closed tuple is just 0. And you notice what happened. I returned here, I didn't say print, I just returned. The result of me having done a comma here implicitly created a tuple response with parentheses. So if I say type this parentheses with a comma, I get an error. It's an invalid syntax. Okay, so the sort of the big picture here is that we have the tuples that look like element comma something. The other thing that's important is that we can't change a tuple once it's already been created. It's an immutable, essentially an immutable array or immutable list, if you want to think about it that way. T2 equals false. I get an error because I actually tried to change something inside of the tuple. T going from 0 to 2, so I'm going to wind up getting how many elements back? 2 minus 0 is 2, comma false, and then 3 beyond that. Let's see what happens. What did I get back? Well, this slicing operator inside the tuple gave me back a tuple in this form right here. And then I got back false, because that's what I asked for here. And then I got something else here. You notice it's a single element tuple. And then the whole thing, as I constructed it, was actually a tuple. So I just created a tuple of a tuple, a Boolean, and a tuple. Probably not what we wanted. Instead, what we wanted is probably something where we do a concatenation. Just like with strings, tuples know how to interact with other tuples and respond back to us with something that makes sense. So what I really wanted is, I want a tuple back from this. I want to just add onto that another element, false, and I want to concatenate that with the last element of the T tuple. Oh no, but we can't actually concatenate, right? So just like when I actually added an integer when I was trying to add it to spam, the string spam, and we had the number 3, we're not allowed to do that either. We have to actually cast it. So the proper way to do it is the following, where we have to have a tuple, we have to add it to with another tuple, and have another tuple here. Okay, that's probably what we wanted back. Any questions about that? Yeah.
How is a tuple different from a list? You see, you can't reassign things through time.
Fundamentally, that's the biggest difference. So I mean, this is a bit of the coding practice, but when I know I've got some immutable data object and it's complex, and I want to make sure that no other code farther downstream from its creation can change it, I'll make it a tuple. If I know I'm going to be passing data around and I don't mind some other part of the code changing an element of it, I'll give it a dictionary or I'll give it a list. What's that? Oh, right. So Varian's reminding me that there are methods. So these are essentially functions that know how to operate on different types. The methods between lists and tuples are different because one's reflecting the nature of the mutability and one's reflecting the nature that you can actually be changing stuff inside of it. So just like with strings, when we had a multiplication, we can do the same thing here. We should get back something pretty sensible. I just got a longer tuple that's basically a double copy of my original. Okay? I think I wanted to show you something else with tuples. No. Okay, so we'll go to lists. Any questions on tuples? Yes?
Suppose we wanted to just add, suppose we have a tuple of numbers and we want to sum of the numbers in the tuple. Do we do an addition this time?
No, so you can't. That's a good question. What if you had tuples where you had a bunch of numerical elements in each of them? and you wanted to essentially, cell-wise or column-wise add all of those. You can't do that with tuples. What you'd have to do is essentially loop over both tuples simultaneously and do the math yourself and sort of emit back a tuple. Sort of typically what you'd be doing when you're doing that kind of math manipulation on arrays or lists is that there's a concept of an array in Python, but we usually use it in something called NumPy. And there you get sort of exactly what you're expecting. You had two arrays or two lists, and you said add these two together, it would add them up element-wise. But in this case, that doesn't work. So there are ways to do it and ways to do it really quickly, but the Python built-ins sort of force you into doing the addition in a different way. Yeah?
Can you build in ordering functions so that you can sort?
Yes, you can. We'll see sorting on lists, and we can actually sort on different elements in the list. That's actually part of your breakout. Yeah?
This question might be a little too early, but in each of these data structures, I'm assuming that the set of inbuilt functions are there to just operate on those things. It's almost like an object class.
Yeah, for those that kind of have already worked a bit with object-oriented programming, each one of these types has a whole bunch of methods that knows how to operate on itself, interact with other objects of the same type. All right, so let's go to lists. It's just like tuples, except it's denoted with square brackets and not parentheses. So here we have v equals 1, 2, 3. We'll print the length of v, the type of v, and you can guess what that's going to look like. It's the number 3, and it's of type list. We can slice and dice that as well. V colon 2, get back the first two elements. V is equal to eggs, spam, minus 1. Whoa, and then a tuple, and then another list. What's the length of this? I hear 5. What else? So we've got 1 element, 2 elements, 3 elements, 4 elements, because this tuple is considered a single element, and 5. Now, unlike with tuples, we can assign things. We can actually say, no. The 0th element of V is not going to be eggs. It's going to be green egg. And number 1 is going to be, I'm going to add to number 1 whatever's inside here. That'll be spam. I'm going to add love it. So I'm going to say spam, comma, love it, period. And then I'm going to look at whatever the minus 1th element is of this list. Okay? The minus 1th element of the list is this one right here, right? That's what we just printed up here. Now, it itself, that minus 1th element is of type list, right? Because it's the brackets. So now I want the first element of this list. So I'm going to get minus 3.5. And I'm going to set that equal to none, and then I'm going to print out V. Okay, so look at what we did in the in17. We changed the first element, we appended to the second element, and we changed something inside of the list that was the last element. So here's the none, and here's the green egg, and here's the spam load. We changed stuff inside of that list. Okay, so let's get everything after that, the second element onward. Oops. Let's make a proto-array out of nested lists. So this is an array, so this is going to be a list of lists. And we're going to have a list here, VV, which will be a 2-element list, and itself will have elements that are themselves lists, which will be 2 elements. So you can think of this as sort of a 2-by-2 matrix if you'd like to. And let's print the length of that. What's that going to be? Is it 4? 2. And if you think of this as an array, you can now create the value of the determinant of that array. And then you just multiply the different elements inside of that array. So think about it this way. The leftmost call here next to the VV with the brackets is saying, slice for me up VV and give me the 0th element. So that's going to be this 1, 2. And then give me the 0th element of whatever comes back. So that's going to be the number 1. So I'm going to multiply 1 times 4, that's going to be this part here, and I'm going to subtract off 2 times 3. Okay? So the main point here is that lists, unlike tuples, are changeable, and you can slice them. They can have heterogeneous elements inside of it.
How does that show that lists are changeable?
I changed them. Up in here, I changed them.
Oh.
I went into V, and I was like, nope, your 0th element is now that.
So if you go to a tuple, it's a tuple whatever.
Yeah, so we did that. We did that with the tuple. Let's see, where do we do that with the tuple? Here. I said the second element is the third element is false, and it said no. You're not allowed to change that. Okay. So lists can be extended and appended. So here, if I have VV equals 1, 2, 3, I can append the number 4 onto that. That does what you think it should. It basically makes the list a little bit longer. And so not only are list elements themselves changeable, the actual length of the list, the number of elements itself, is changeable. We think of lists as objects, and objects are like animals. You can think of them like bears. They know how to do stuff like eat and sleep. They know how to interact with others, like have babies. They have characteristics like height and weight. And knowing how to do stuff is called a method. And in this case, this append method, where it's basically denoted with a dot, when invoked, is an action that changes the characteristics, the data vector of the list itself. And sometimes we call characteristics attributes. So there's actual data associated with this V, and there's a bunch of methods associated with this V. Okay, let's go back to the notebook. Okay, so here we're back where we're going to show extending, appending, and popping. So here I'm going to set a vector or list V equals 1, 2, 3. Append the number 4 onto it, so now V will be 1, 2, 3, 4. And I will append -5 to the end of that, but with brackets. So now I got probably something I didn't really want, right? Let's say I had another list, -5, -6, -7. I just want to tack that on to the end of it. It's not exactly what I want here. You see, I wound up getting a 5-element list back, but now I have 4 ints and 1 list as my elements. So we'll see a little bit how to deal with that in a second. So V equals V colon 4, so I'm going to grab up everything to the end here, and then I'll say W is equal to elderberries plus eggs, and then I'm going to add the 2 together. And just like tuples, we can add lists together, and those lists don't have to be of the same element type, right? So I can have a list of strings and a list of numbers, and I can just stick them together. If I want to tack on elderberries and eggs onto this other list, what I can do is use a method called extend, which takes V and extends it by W. This is different than append. Append sort of sticks that stuff into new elements. Extend is really, in some sense, the addition. So I got the same thing as I had here. The plus sign and the extend basically do the same thing. Pop. So this is now thinking of these lists as sort of containers or queues, and pop just sort of removes an element out of that. Let's see what happens when I pop. Eggs. What it does is it takes the last element out and it just removes it. So what happens when I say print V? It's gone. Right, so I didn't say V equals some other representation of V with some method, pop that, right? In memory or in place, the values associated with this variable V have just changed. And so now v is smaller than it was before. If I said the length of whatever comes out of this, before I would have had 6, and now I've got 5. I can pop explicitly an item that I want by indexing where I want to pop it out from. So now I want to pop out the first one. So if I wanted to create some sort of some buffer, like a FIFO buffer or LILO buffer, you can put stuff into this list, save stuff, and then when you want to get something out of it, you can pop it. And you can pop it wherever you want to pop it. So what is that going to be? I popped it, and you notice I didn't print the result of me having popped it. I only printed out the result of v afterwards. Whenever you have these semicolons, the first thing on the left is executed, then the thing on the right is executed. I could have another semicolon after that to be executed. What if I executed this again? This is a nice thing about the notebook, by the way. So you can go back in and say, no, that's not really what I wanted. I'm going to change those codes. Except now I've actually changed v. So v is different than what it was when I ran 28 last time. That's the 28th command I've run. What happens if I try it? Right? Because v is just changed, and I try to pop again. I pop again. What's going to happen now? It's an empty list, and I want to pop out the 0th element of it. You idiot. No, that was me, not you. So pop from an empty list. So, right, you get back sort of what you think should happen here. Okay, so append is a method that adds new elements. Extend concatenates a list, and pop removes an element. Lists can be searched, sorted, and counted. This is a question about sorting. So here's my original vector list. If I sort it, there is a concept of sorting that can deal with this heterogeneous type. In principle, you could stick a type in here that doesn't know how to be sorted, but Python tries to do the best it can with this built-in sort function. And what it did is, again, it changed v in place. So notice I had 1, 3, 2, 3, 4, and it just said, okay, I know numerically how to do this. The letter E I'm going to stick at the end. Reverse is a keyword of the method sort. We're going to see more of this stuff as time goes on. So here I say v.sort reverse equals true. So you can bet that the default of reverse is actually false. If I print this, what's this going to say? Elderberries 4, 3, blah, blah, blah. Is that clear? The important thing about sort is that it changes the list in place. If I want to look up the index of the number 4, I can find out where, given how I just did this sorting, where it should be. What number should that be? Where is 4? What element is 4? It's the first, right? So that's the 0th element. That's number 1, 2, 3, etc. What's the index of 3? How come I didn't get back a list? I have 2 3s in my list. Well, what index does is it responds back to you with the first element that essentially matches what you've asked for. So if I want to know how many 3s there are in my list, I've got 2 of them. Right, there's my list. So the first 3 was 0, 1, 2, and I've got 2. I can count them in my list. So now I can know how many elements of different types I've got, or different numbers inside. Let's say I want to insert something, and this is essentially the opposite of popping. I can insert the 0th, at the 0th place, it's full of stars, and I can print out the value of v, and I've just stuck in this value, okay? What if I want to remove the number 1? Well, that's sort of like popping, except I'm explicitly saying remove something that's whose element is equal to the value of 1. And I remove that out.
Why is that not removed from?
What's that?
Why is that not remove whatever's at position 1?
So that would be pop. If you want to remove something at position 1, you say pop 1.
Okay.
Okay. What else are we going to say about lists? So I've been telling you about all this cool stuff about methods, and one of the things that you can use IPython for is to actually help you explore what's available for that object. So go into IPython and say v equals, bracket 1, 2, 3, so you create a list. And then type v dot, and then press the tab button. Whoops. Don't do what I just did. Where am I? I just killed it all. Oh, I pressed tab instead. Okay. I'm getting confused. This is too meta for me. Now I lost my mouse. Okay. Okay, tab. Everyone got that? That was just a keynote bark. That wasn't actually a Python bark. So v.tab, and this stuff pops out. And you go, whoa, what are all these underscore things? Many of these things, these underscores are kind of methods that you don't traditionally use. They're not thought of as being exposed to the end user. They're sort of private, but all of these are methods that we actually want to use, and I think I've introduced you to all of them thus far. So these are the special methods. We generally don't use them. In advanced use cases, you might. If I now type v.re, because I know I want to do something that starts with the two letters re, and I press tab again, it'll show me, I can do v.remove or v.reverse. Okay, what is remove? If you say v.remove and then question mark and press return, it actually tells you something about what this actually does and what the different keywords are, or how you call this method. So in this case, I've got a list and it says remove, and I just remove a value. Removes the first occurrence of that value. Hey, IPython allows us to essentially get into the documentation at the function or method level and tell us how we should use it. This is not a very descriptive statement about how to use it, but it's pretty clear what it does, right? In many other cases, especially for third-party codes that are used very often, is that you'll see very descriptive documentation that gives you even use cases and examples. And that's really nice. Yeah?
Would be a similar list of methods using conventional Python.
You can say help. You won't do the tab completion. That's sort of a IPython magic thing. But if you said help v.remove and put parentheses around it, so help parentheses that, you would get the same thing out of it. Yeah? Go ahead.
I don't actually get all the list of the underscores in your site. I just get the starting at v.10.
To do v.underscore and do an auto.
Okay, so Dan's saying v.underscore and then try a tab. So the old version of this is a slightly older version of IPython when I made this, apparently just showed you everything. And now you have to explicitly ask for all the sort of magic stuff underneath. Okay, let's do dictionaries. I think that's I don't know, where are we going to do sets? Okay, a little bit more on lists, and then we'll go to dictionaries. So here's an iteration over lists. So now we think of these lists not just as containers of elements that may contain data of interest, but now we can say a equals cat window defenestrate. You can look that up if you don't know what that means. And now we'll do a for loop over that list. So this is how we use for loops in Python. For x in A. So what it's saying is every time you go through another iteration of this loop, set the value of x to be the next element of what's in A. So this is really nice because you don't have to sort of create indices, right? I'm not even saying use the 7th element and sort of bump up an index. This is what you would do in C, for instance. I can basically just loop in line from each of the different elements. So the first value of x is going to be cat, and I can get the length of that, and I can print that out, and then window defenestrate cat 3, window 6, defenestrate 12. If I actually want to have the index, so I want to know how many loops have I been through so far, you can use a built-in function called enumerate, which will return back actually a tuple, but I can immediately assign the values, the element 0 and element 1 of that tuple, to be I, which I'll think of as the index, and X, which will be the same thing up here, which is the different elements in place. And then what I'll do is I'll print out I, X, and the length of X. So if for some reason you need to actually have an index as you loop through, you can grab that index in a really nice way. But now you notice I don't have to just loop through an index and then go into A and say, give me the ith element of A, and call that X. I do that directly in the for loop call. Something nice about the way that sort of Python 2 works is that you can add a comma after a print statement, and it says don't unnaturally add a new line unless I've asked you to do that, but add a little space. So instead of having to scroll all the way down and see 3 different line outputs, I can see it all on the same line. So the syntax for iteration, which is actually true of any iterable, so anything that can be iterated over, which isn't just lists, it's also tuples, it's also sets, it's also other types of variables, and even things like files, once they've been opened, you can think of looping over them. If they have a concept of being iterable, they will be able to be looped over using this syntax. And you notice this is not right because I haven't put a pass here, I haven't done something inside of here. But for variable name in iterable, so it's in turn assigning the variable name to every next element of the list in turn.
Do you run the for in the IPython, or do you have to be in the notebook?
This should work in IPython. It should work in Python.
How do you execute it?
In IPython? In IPython, either you can do what I'm doing, where I'm running the selected cell, or you can press Command Return as you're typing this out, and it'll execute that cell. And what it's doing is you're essentially, in IPython, you'll see more of this when we talk about IPython in the afternoon, you basically build up whatever you want to do Python-wise inside of a cell, and it doesn't actually execute any of it until you press Control Return. It sends all of those statements over to the IPython interpreter, which generally will live somewhere else. In this case, it lives for me in a terminal somewhere, but it could live on the other side of the world, serving you your IPython, interactive world. And once you send it over, it does what it can, and it sends back the results, and it renders it for you. Yeah?
Just a point on the Mac, to execute a cell in the notebook, it's Shift-Enter.
Shift-Enter? Oh, maybe my muscle memory isn't working. Indeed it is. That's why it wasn't working for me before. I don't know why I was thinking command. Thank you. It's shift return and not command return. That would explain why I was confused. Okay, we'll talk about the range function. If I want to say range, I basically, let's see what happens when I say range for print x. And we'll see what the output of all this is. Oh yeah, of course. And then I can get rid of all this over here. Although now it's off to the side. That's so nice. Okay, let's look at what happened here. What did range for do? It basically created a list for me that goes from 0 up to 4. And it did it so if I wanted to iterate over it, I could use it. What does that mean? Well, I'm creating a list of essentially 5 elements up here, and I'm going to loop over, and I'm going to have a value associated with each element of this in turn as I loop through. So I'll say the total, which I'll start off at 0, I'm going to add to that total that value. And by adding that value, the total is now that. So by adding 0, the total is 0. By adding 1, the total is 1. By adding 2, the total is 3. By adding 3, the total is now 6. Okay? Here's how we call range. It's basically a stop. That's the only thing you have to give. And when you look at the documentation for range, you'll see a bracket, which those are generally considered optional. And then other brackets, those are also considered optional. So if I only give it one element, it's going to be the stopping value, and it's going to start at 0 by default. If I gave it 2 elements, it would tell me where to start, and it would tell me where to stop. Now, if I gave it 3 elements, it would tell me how to step through that. Yes?
Does it create a real list on an iterator?
It creates the range creates a real list. So we'll see something in a little bit called X range, which creates an iterator. So if you say X range 10 to the 9, it'll take a little while to populate, a place on memory with all of those elements. If you say X range 10 to the 9, and not just range, it will basically do it immediately. And then it'll allow you to iterate over that. So it only uses those elements as need be, just in time. Okay, so total equals 0 for val in range. So I'm going to now use range in this way. I'm going to start at 1, go to 10, and I'm going to step by 2. So I'm adding 1, 3, 5, 9. So I started off at 1, I counted by 2, and I stopped when I got to 10. But you notice the next element would have been 11 if I kept on going, and so that is not allowed because it's at max 10. Yes?
Is range only for integers?
Range is only for integers. There are ways to do things with, if you really wanted to, and knowing what you know now, you could basically loop over the results of what comes back from range and create a float version of that, for instance, or a complex version of that.
Range actually stopped at 9?
Range stopped at 9 because what you're saying is the stopping is at 10, and it's the max value that you can associate in the list. And the next one should have been 11.
But being a base 0, would it not actually just stop at?
No, this is the actual value of what it's allowed to stop at. It's not the total number of elements in that. So when I said range 4, I actually got back 5 elements from 0 to 4.
When I do range 1 to 10, I get 1 to 9.
Is it range 10?
Josh, it's up to but not including.
Up to and not including. Okay, thanks. But then why did I get... Oh, yeah, sorry. Okay, I was thinking I got a 4 back. Yes, thank you. This is not saying give me 4 elements explicitly. This is saying where to stop. So it's less than equal. Not less than and equal, it's less than. Thank you. Okay, so let's make a list. Mary had a little lamb. I'm going to loop over the length of this list, which will be 1, 2, 3, 4, 5. And I'll basically loop over this. And instead of doing what I said before, where you can just say the in, I'm actually going to loop over the index of these elements, and then I'm going to print out the ith version of that. So this might be a little bit more familiar if you've been using C. Any questions about this? Yeah.
How do you do a non-uniform indexing in the lists? So if you have a long list and you want to index another list of numbers, and you want to have 10 numbers that are non-uniform, how do you index?
10 numbers that are not uniform with it. So you want to slice up the list in weird...
I want, the non-uniform set of slices out of that list.
You generally would do that within arrays. You think of that usually with numbers, and you generally would do that with arrays. And then if you're doing things with arrays, you'd use something called numping, which we'll see some of, I think, at the end of today. So you do these sort of crazy slicing and dicing in a somewhat different way, but similar syntax to the colons that you saw before.
So you're forced to basically loop through if you're going to do anything.
So you can do it. You can brute force it. If you've got a 1,000,000 element array and you say, I want the 17th element as long as it has the letter A in it, you can just go through element by element. But there are ways to do it really fast and with basically C helping you under the hood if you do that within NumPy. Okay, let's go on to sets, denoted with curly brackets and not the right arrow brackets. So here's a set. It's of type set, and you notice something immediately right away. This is different than tuples and lists. What happened here? I got back some random ordering or somewhat random ordering of what I put in. When you think of a set, there is no ordering guaranteed in how the elements within that set wind up living. And if you need something where ordering is guaranteed, you should be using a list or a tuple. Sets are really just the construction of how we think of sets. It's just a bunch of stuff, right? And there's no guarantee at all how that will wind up being, how that will live on disk. You can still iterate over it, but it's not usually advisable. The type of that is type set. The type of those curly brackets is of type dictionary. So we'll see that when you have these curly brackets, we're going to create a dictionary. We'll see that a little bit later on. If you really want to create an empty set, you say set and then with parentheses. What do you think happens when I say set spam IM? Well, what the set constructor does is it says, oh, everything inside of here is got to be an iterable. Well, a string is an iterable, so it's going to look at every character of spam IM, and it's going to basically pull out the unique elements of that. So I don't have two A's there, I don't have two M's, but I have all the different elements of spam IM. If I really want to just have a set of spam IM by itself as a single element, I'd have to put brackets around that. Is that clear? Because what's the iterable here that set is being passed? In the case of these brackets, it's being passed a list with a single element, and so that is itself going to be defining the set. Yeah. So what I've passed to bingo here, so in this case, this is just how you can construct it. You can also go up here and say, so what I said here is basically go through and loop through the elements and save all the unique elements of this. Bingo itself is an iterable, but it is an element of the list that I passed to set. So it's not going to get iterated over. It's being considered a single block, a single element. Yeah?
So between 55 and 49 that you've done there, 55 is just a set with one entry, right?
Well, 55 now has 4 elements in it. It's a list with 4 elements. So set loops through that and says, is this unique? Yes, I'm going to take that. Is this unique? Yes, I'm going to take that. And it just does this until it gets to the end of the iterable. That didn't happen here because I gave it a single string without the brackets, and it looped through that and says, oh, how do I iterate over this thing? Oh, I'm going to consider this an iterable. Is S unique? Yes. Is P unique? Yes. Is A unique? Yes. M unique? Yes. I unique? Yes. A, no. M, no.
You're using iterable without really defining what it is for people who aren't used to languages with iterators.
I mean, I think you're right, but I think the way to think about it is when you think about what is something that can be iterated over, I'm thinking just semantically in English, something that's iterable, and I haven't given you the deep meaning of it in Python, but it's something that you can essentially step through. And you can think of it as something that can be looped over or something that has elements that I can wind up indexing in turn, right? And there's an order to it. Sets have unique elements. They can be compared, differenced, and unionized. So I'm going to create a set. So this is going to create a 2-element set with S and P. B is going to be a 2-element set of A and M. I'll print A and B. C is some other set, A and M. And you notice that I created B with the set AM, but I'm going to create set C with A, comma M, because I've now created a 2-element iterable in the form of a list. And I'm going to evaluate whether C and B are the same. And the answer is true. Is P inside of A, or P in A? Yes, because it's up here. Is PS in A? No. Why not? Because this is basically, you're asking, is the element PS in A? What if even though I created set from SP, what if I did this? Is that going to work? No. Okay, what is A? It's just P and S, a set of P and S. Okay, Q is equal to the set spam IM, that's what we had before. A is subset of Q. Yes. So A is P and S, and the elements of P and S are a subset of whatever is in Q. I can print out Q. Right? There's P and S, it's in there. I can do concepts of ORs on sets. I can do subtractions on sets. So I can say A or B and subtract off all the elements of that from set Q. And I can do ANDs. So like lists, we can think about these as unordered buckets, and we can pop stuff off, and we get some random element. It's not really advisable to do this, but you're allowed to do it because you're going to get different results on different architectures. So for I in whatever this thing is here, this Q union with, or ANDed with A or B, I'm going to print out this result. If you guys do this in your different machines and actually execute this directly, you're going to get a different order. At least this order won't be guaranteed. I can remove elements from the set. I can pop stuff off that set. I can keep on popping. Keep on popping until I get nothing left. Just like when we're popping stuff off the list, there's nothing in there, you get an error. Sets are fairly new to the language as a built-in. They've been around for a while, but you know, you'll obviously be able to find some place for them in your own code. So when we think about dictionaries, they look a little bit like our set construction, except they're these things with colons in here. So favorite cat, none. I don't like cats. Favorite spam, all. And the way that you think about a dictionary is a key and a value, a key and a value. And just like with lists and tuples and sets, each element of a key, of a value, can be whatever it wants. So it itself could be a dictionary or a tuple. Keys have a little bit more restrictions on them, but even keys could be tuples. So the way that I index D, or I get at various values of those, is I do essentially a lookup. And I say, okay, for the favorite cat, what is that? None. D0, this is not a list, so we don't have a keyword 0, right? This is different. We don't think of these things as sort of ordered lists or tuples. There is no keyword 0. So I get a key error 0. Let me create something else. E is equal to is a dictionary where one key is favorite cat. And you know it's a string and it can have spaces in there. It's none. Favorite spam, all. And the number 1, which if you ask Google what's the loneliest number, it will respond by 1. And I can ask, is E1 the loneliest number? And the answer is true. So now, if I really, really wanted to have something that looks sort of like a list, where I can index it with numbers, I just make my key an int. Now this is weird because I have like kind of mixed key types, right? So I've got 2 string keys and I've got 1 int key. And I've got 1 variable which is of type none, and then I've got 2 other strings. And notice also I have a single quote here and a double quote here. All that stuff is legal within Python. It's not advised to make it sort of this heterogeneous, but you can do it if you need to. E, if I just now essentially print out E, you notice I get it back in an order that's different than the order in which I constructed E, just like with sets. So there is no guarantee that I'm going to wind up getting back the same order. So don't think of sets or dictionaries as some container where you preserve that kind of order. It turns out there's actually an order dictionary which is starting to come into the language. And probably in a few years it'll be totally built in, but you can get access to that if you really needed it. But generally think of these dictionaries as unordered. Okay. I think I'm going to do a little more dictionary work. Yeah, do a little dictionary work. Constructions of dictionaries. Favorite cat, none. Favorite spam, all. That's one way to do it. Another way to do it is say what the keys are going to wind up being and what the values are going to be. Key, value, and then I'm going to print this out. And I cast it with this thing called the dict. But you notice now that my key, which once was just basically cat, is now a string called cat. So Python will say, oh, what you really wanted to do is make that a string. So I don't usually use this construction here. Another way to do it is just create an empty dictionary with the curly brackets and just start filling it up. Just say, okay, there's a key called cat, and I'm going to have a value associated with that with dog. There's a key called 1, a value associated with that called the number 1, and then so on and so on. If I now print that out, I have a dictionary. And then the last way to do it is you can have a list of tuples. So you have what will become the key, and that's its associated value, key, value, and then I just say dict my list. What's interesting is I can say, look, so here's how this got printed out, right? So if I ask the same thing here, and you notice when I printed out D, I got sort of a different ordering here. I get true. That's not the same thing as if I had a list and the elements were 1, 2, 3, 4, and I compared it to another one whose elements were 3, 4, 2, 1. That would not be considered the same, being the same. But in this case, again, we don't think of ordering, and so what's actually being done is at the key value level, there's this inner comparison, and if they're all the same, then it's all okay. Dictionaries can be complicated in a good way, so again, let's start back with D. I can actually now do, call D something else. I can have a key of favorites, and now I can say, well, I've got a dictionary with a key of cat and a key of spam, least favorite cat, all, etc. So I have essentially nested dictionaries here. So I can say my least favorite cat is all of them, and I could say my least favorite spam, none of them. So these are kind of nice containers that you can pass sort of complex data structures around. You can change them on the fly, and you can add to them as need be, which is pretty nice. The nice thing I haven't showed you yet is that if you've got a really long line and you want to make your code readable so it's not going way off to the side and gets cut off in some text editor, you can put a slash here which just says, I'm not really done making my statement yet. Wait for it to complete. So I've created a little phone book here, family. Here's now a list, not a dictionary. My mom, phone number, dad, phone number, friends, Billy, blah, blah, blah. And I can now loop over friends and family. So I'm creating basically a list. And I'm going to loop over, so group type will have at the beginning friends. The next time I come back up, it'll be family. I'll print out the group type. And then I'm now going to do another loop inside of that where I'm going to look at phone numbers. So that's this variable. I'm going to go into the group type. So the first time I'll do that, I'll grab friends. And inside of that, so I'm going to create a variable called info. Inside of that, I'll be pointing to the 0th element and the first element as I loop through. This is only a single element list of friends, Billy. But itself is a tuple, and it has 2 elements in it, Billy and here. So what I'm printing out here is the name and the phone number. Is everyone okay with that? Any questions? So nested for loops, we're seeing that for the first time. We're seeing basically the key lookup. So 0 and 1, why am I using that? I just said that we're using dictionaries, but in this case we're not, because we're actually just looking at tuples, 0 and 1. So that is actually well defined. Yes?
So I have two questions. The first one is the info. Would that be a command? Or...
No, so info is a variable that's getting created and getting assigned a value each time I loop through here. And in this case, within a given group, I'm going to loop through all the phone numbers I have. So in the case of families, I only had one phone number, or friends. In the case of family, I've got two phone numbers, so it's going to loop twice. And the first time that I loop through here, when I have group type equal to friends, info is going to be assigned the value Billy, comma, whatever that phone number is. Yes?
Do you have an example with like a long list of numbers? Because there you have equal 0 and equal 1, but in a given case in real case you would have like 10 different algorithms. So,
Yeah, you'll get to play a little bit with the sort of mixed types and stuff in the breakout session. Yes?
You use the MyList to turn a list of tuples into a dictionary?
Yes?
Okay, so is there any way you can, like, I guess, convert between different types of
Yeah, so the question is converting back and forth. I'll show you a slide on that. Okay, if I want to know what all the keys are within phone numbers, I can create a list, and that just gets me family and friends. Thing to note here is that we don't know which order this is going to come back in because the dictionary itself is unordered. So I don't know whether friends or family are going to come first. I can get all the values associated with the keys. And again, this dot thing means that keys and values are actually methods that are called on types of dictionaries. So instead of having to explicitly say friends and family to create a list to loop over, I can just say, okay, I don't know what's in there, but let me just loop over all the keys, and let me just see what I get back out of that. So I should get back the same thing. In this case, I didn't know whether friends or family would come up first, and on different machines, you'll get back a different ordering. So if you really cared to have friends first and then family, you would have to deal with that, and actually explicitly say I want friends first. So we don't know the ordering. But one way we can ensure that it's always the same on all machines is to get that list of keys, sort that list, and that sorting will be preserved across different architectures, and then I can print that out. So this is a less volatile way, and you notice family came before friends, which it should, and because of this A coming before the R. Okay, so there's another method, which is called iter items. It's a little bit like enumerate for lists, but this is for dictionaries. So group type and vals. So now I'm going to populate two variables as I go through this list. This is the key. This is the value associated with that key. And I'm going to loop over using this thing called iter items. So what it's going to do is it's going to go into this dictionary, and it's going to say, okay, assign group type equal to family, and assign info equal to all this stuff here. So here we go. So now we get to loop over very much more succinctly, and we're getting back something pretty sensible. So there's lots of different ways to do the same thing, but I'm showing you this just to give you some sense of when ordering matters, how we do sort of iteration over these complex types. Yes?
Can you sort the items on the block?
You could, so it is actually returning back an object which is iterable. I don't think it's sending back a list that then gets iterated over. So I believe unless iter items has a sort keyword associated with it, it will just return back whatever order it wants to give it to you. So the way to really do it, where you're being very careful about preserving order, would be this. And I'm not sure if, Paul, do you know if iter items has been deprecated in 3? I heard some. Yeah, I think iter items is falling out of fashion for some reason. All right, let's get some values. Oh, so phone number of my coworkers. I don't have coworkers, so I get a key error. I can ask something more graceful. Let's say I don't want my program to barf on me. I can say, does it have a key or has underscore key? False. So it's giving me back a Boolean. I can do a get, which will basically give me back the value of the coworker's value, if it's there. If not, it will return back a none. So that's pretty graceful. Phone numbers.get friends equals phone number friends. So these are really two different ways of looking up the values associated with the friends keyword. And those are the same. And if I want to go look at get, and I actually want to have a default value in case there are no values associated with that, you can do the key that you're looking for and then the default that comes back there. Instead of getting back a none, you get back whatever else you want. We can set values, so phone number friends.append. So let's see what that looks like. So I actually just said, oh, well, the value of friends associated with this keyword friend, or the key friends, is a list. And I know how to append to lists. I can add Marcia on top of that, right? So now Marcia is part of my friends. What if I did this again, by the way? What if I ran this again? I get 2 Marcias. If this was a set instead of a list, and I try to add Marcia again, I wouldn't get it. Right? Billy's phone number changed. He moved away. And so I can access Billy by going into friends. I know that Billy is the 0th element of friends here, so that's this 0. And I can go to the first element of that tuple, and I can assign it what I want. Oh, but you can't do that. Why can't I do what I said I could do? Because tuple does not support item assignment. We can't change a tuple once it's been created. I can change elements of a list. So I can just say, okay, the new thing is Billy this, right? And that should be legal. It is. I lost all my friends preparing for this Python class, which is true. Phone number, friends, I'm basically going to set that to an empty list. I'm going to pop off all my friends. I don't have any. Let's print the phone numbers. So I actually had an empty list here. Let me try this. So you see I have an empty list. And I say, well, if it's empty, why do I even need this key here, right? So I'll just pop off that key. So again, dictionaries have this concept of pop. And I can print the phone numbers. And if I really want to, instead of popping, one way to do it is actually delete that key. And you do this thing called del. And if I print the phone numbers, I've got an empty dictionary. Update is very handy, like append for lists. Phone number.update. Friends, so I can add stuff back in. And that's really how you wind up changing a dictionary sort of in place. Okay, so casting back and forth. We can go between tuples and lists. So here we've got this crazy A here of basically a list with 4 elements in it. I can make a tuple out of it, and you notice that all I really did was just change from the square bracket to the parentheses. I can make a list out of the result of that, and I get back what I had before. I can create a set out of that. I can create lists out of sets out of lists. Usually when it makes sense and you need to do it, it'll be clear how to do it. But one of the sort of important things in this casting is that you're not sort of cascading through the whole thing. When I say make this thing into a set, all you're doing is going through, let's say, a list, and you're basically taking that whole list and you're turning the whole thing into a set, element by element. You're not actually digging into each of those elements and casting those also as sets. Okay? So if you've got a long list and you want to basically make a shorter list that only has unique elements of that list, cast that list to a set, and then cast that set to a list, and all of a sudden you've got only the unique elements of that list. When we did these loops, in some ways this gets into this slicing and dicing question. We wanted to say, let's say we have this crazy sort of, I want to have a list of all numbers from 0 to 10. whose lowest 2 bits are both 1, but not divisible by 11. Again, because crazy, and I want to know that. So here we go. That's the answer. And I did this by looping over all the numbers less than 101, not less than or equal to 101. And I asked this question if I do a bitwise AND with 2, a bitwise AND with 1, and this number is not equal to 0, that is the mod operator, I don't have any remainder, put it into my list, and I appended it onto my list, and I got back my result. List comprehension is a sort of nicer, cleaner way to do that, where basically you create a list on the fly, and you basically stick your for loop inside of that list. This works for dictionaries, by the way, and sets, but usually these are only done on lists. So here's what's going to happen. The elements of this list will be the value of num. For every number in the range 0 to 100, if this whole thing evaluates to true. And what happens is Python looks at that and says, oh, you wanted me to iterate over this thing here, populate it with num, evaluate this truth statement, and populate this list with those values if that truth statement, if that evaluates to be true. Yeah?
Statements like this, how do you know for sure what the order of evaluation is? Say if you get a long set of things.
So you usually do these as sort of one-offs. You wouldn't try to coerce your 17-line for loop into one of these. And you can do this in a nested way where you have the equivalent of multiple for loops. I think once you get beyond one for loop and you're just asking essentially a few line question on the data where you're just sort of looping through something like in an existing list or you're creating a new list, that's where I would do it. But once it gets bigger than that, forget it. And once you know that this is how it works, you basically, in the middle of it, you have your iterable. You iterate over that. You basically have a truth statement or not. If I didn't have any of this, I would just get back that. So if I got rid of all of this, there's nothing to evaluate to be true or false. And so I would just get back every number from 0 to 100. But I could also just do that with range. Okay, so I get back the same thing. Here's a little bit more of a complicated example with particles. I've got a list. So the outer part here is a list. Okay, so I've got a list of things. Those things happen to be a list of dictionaries. And those dictionaries themselves have 2 keyword value pairs, right? So keyword value, key value. So name is pi plus, mass is some number, blah, 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 right? If I want to get all the mesons that have a mass less than 1,000 and a mass greater than 100, what I do is I loop over all the particles. So I'm now assigning a value to x. And what is x? When I loop through this, it's going to be a dictionary. And what I'll do is I'll save a tuple of name and mass that basically matches this, this filter. And if I want to get the average of all the mesons in that mass range, total equals 0, and then I can say 4x equal my mesons, total plus equals this second element here, the mass. You notice here, if I only have one thing to evaluate inside the for loop, you don't have to put it on an indented line. The average of mesons in this mass range is I'm going to cast to a string, the total divided by the total number of mesons that pass this. And if I want to print out the name of the meson that passes that, oh, that's ugly. That is some representation. You see here, I've got this nice little pi here. I've got other Greek alphabet elements. This is how Python is representing the string internally, and it's just showing me how it represents it. If I actually print that out, I get a sort of nice representation of that as best it can within the interpreter. This is getting into a little bit of the sort of beyond the standard ASCII stuff that we're going to try to avoid, but sometimes it is unavoidable. Okay, so we're ready for the breakout session. Any questions before I introduce it? Good. Okay, here's the following data. This lives, by the way, in airline.py, which is linked from the website. So go grab it. You've got a bunch of airports, and this is a dictionary. So it's got basically the 3-letter code that resolves. This is the key. That's the value. Resolves to the full name. You've got a bunch of different flights. Southwest, that's the name of the airline. That's the flight number. That's the airport that it's leaving to. This is the gate number, and that's the total time, or that's actually when it's going to fly out. So it's using these two pieces of data. So you've got a dictionary, and you've got a list. And you notice that list has tuples in them. Print out a schedule that's organized by airline. So it should look something like this. Don't worry so much about the actual total numbers of spaces. You can try to get that working right. But just try to make sure that you're organized by airline. So all the Southwest airlines, make sure you print them all out together. Although I don't really care which order they're in. Print out a schedule organized by time. And to do this, you're going to have to do sorting on the last element of each flight before beginning the printing loop. Okay, go for it. So if I go to this first cell right here, I say t equals 12 minus 1, and I can print the type of that. Hopefully. It's not working. I have to dump out the notes.
Run selected.
Yeah, it should just work though when I'm typing. Oh, I'll just do this one. Okay, so there's our answer for our first one. So I just created some object called a tuple, and if I want to now ask is t of type tuple, and ask for the length of that, I get true, and length is 2. So now we think of what the tuple contains as basically a bunch of different elements. So now I'm up here in 3. T equals 12, Monty, true, minus 1.23 exponent 6. You notice right away that if this doesn't give me an error message, then it means that tuples can contain a mixed different type of variables. So here's an int, here's a string, here's a boolean, here's a float. And if I print the first element of that tuple, not 0, there's the first one. I get back Monty. Okay, that's really nice. All of these things that we'll be talking about essentially can contain a heterogeneous set of objects.
Okay.
So now we're going to talk about some advanced data types beyond just string equals spam. We'll be talking about really 4 built-in types. Can everyone hear me okay? Try to get a mic. We'll be talking about 4 built-in types. And we'll just go in order: list, tuple or tuple, sets, and dictionaries. And the way to think about all of these is that they're essentially sequences of objects. Some of them are changeable. Some of them are not changeable or immutable. And they all have different properties, and you're going to wind up using them, not necessarily all of them in every code, but many times you'll wind up using different types to sort of satisfy different needs within your code. So I'm going to start off with tuples, and what I'm going to do is present this to you through the notebook. I think I can just get rid of that. So this is the IPython notebook, and you see I've basically kind of laid out where we're going to go with all of this, and I haven't told you the results of any of it yet. So this is sort of a nice thing, I think, hopefully for teaching purposes, that you can have this notebook saved. In fact, we have the PDF of this notebook, a raw version of the notebook, and also a markup version of this notebook, also linked from the website. Okay, so tuples. Those are denoted with parentheses. What did I get back? Well, this slicing operator inside the tuple gave me back a tuple in this form right here. And then I got back false, because that's what I asked for here. And then I got something else here. You notice it's a single element tuple. And then the whole thing, as I constructed it, was actually a tuple. So I just created a tuple of a tuple, a Boolean, and a tuple. Probably not what we wanted. Instead, what we wanted is probably something where we do a concatenation. Just like with strings, tuples know how to interact with other tuples and respond back to us with something that makes sense. So what I really wanted is, I want a tuple back from this. I want to just add onto that another element, false, and I want to concatenate that with the last element of the t tuple. Oh no, but we can't actually concatenate, right? So just like when I actually added an integer when I was trying to add it to spam, the string spam, and we had the number 3, we're not allowed to do that either. We have to actually cast it. So the proper way to do it is the following, where we have to have a tuple, we have to add it to with another tuple, and have another tuple here. Okay, that's probably what we wanted back. Any questions about that? Yeah.
How is a tuple different from a list? You can see you can't reassign things through time.
Fundamentally, that's the biggest difference. So I mean, this is a bit of the coding practice, but when I know I've got some immutable data object and it's complex, and I want to make sure that no other of this empty thing here, I'm going to wind up getting a tuple without the comma. If you try to create a tuple with a comma and nothing else, it will complain at you and say, I don't know what you're talking about here. So if you want one element, you need to do that element and a comma. If you want a no element tuple, because that's how you roll, you just want to do it with open and close parentheses. The length of open and closed tuple is just 0. And you notice what happened. I returned here, I didn't say print, I just returned. The result of me having done a comma here implicitly created a tuple response with parentheses. So if I say type this parentheses with a comma, I get an error. It's an invalid syntax. Okay, so the sort of the big picture here is that we have the tuples that look like element comma something. The other thing that's important is that we can't change a tuple once it's already been created. It's an immutable, essentially an immutable array or immutable list, if you want to think about it that way. T2 equals false. I get an error because I actually tried to change something inside of the tuple. T going from 0 to 2, so I'm going to wind up getting how many elements back? 2 minus 0 is 2, comma false, and then 3 beyond that. Let's see what happens. Objects or variables inside of them. So you could have dictionaries and tuples all sort of interleaved with, inside of each other. Okay, T minus 1. What's that going to print for me? What's the minus 1th element of the tuple? Minus 1.23, yes, exactly. And notice it didn't print out this, it printed out the string representation of that. Okay? Minus 2 to the end. So I'll get the last 2 elements and I'm going to return that as a tuple. So we're basically using the same sort of notation that we had when we were slicing and dicing up the strings. True and minus whatever. Okay, now this is an important thing in constructing tuples. X is equal to, just like I said, parentheses, true. And I'll ask for the type of X. Then I'll say X is equal to true, comma. If you put parentheses around something, what Python natively wants to do is just evaluate it. So Python just put parentheses around it. It's as if I said X times 5 equals, or plus 4, right? And it would just evaluate that. That's what these parentheses mean to the Python interpreter. So to say, no, I really just wanted a one-element tuple, you actually have to add a comma afterwards. This is a little bit of a quirk, but hopefully it should make sense. So if I ask for the type,